Welcome to our channel. Today we are going to discuss about earthquake analysis using MATLAB code. So for the earthquake, we are going to discuss about the values given values which is generated during Loma Prieta earthquake. So this earthquake happened in 1989 year in California. So we are going to discuss about the MATLAB code. So here we have saved that in the file named quake.mat. So all the values generated during that earthquake is saved in the under the dataset named quake. So this quake.mat, it has 200 hertz data generated from the dated on October 17, 1989. Okay. So now we are going to see the coding. So first you have to load the quake value, then list out the variables present inside that data set. Consider the time equation as 1 by 200 into seconds of 1 is to length of V. Length is nothing but which gives the biggest value. It will check the number of rows and the number of columns. Whichever is higher is considered as the length. Find the time from the workspace variable. Variable names, what are the things we have used is nothing but the directions, east to west, north, south, vertical. So then the quake data value is tabulated as time env variable names. Variable names are nothing but the position names. Head of quake data. So it is plotted as figure comma plot of quake data dot time comma quake data dot east west. So with respective to this east west, we have generated the east west acceleration. Then the variables are nothing but they are updated as 0.098 into quake data dot variables. The time value is calculated as we are taking the time value from 8th second and 15th second. Hold on the figure value, plot T1 and the T2. The line width should be 2. The plotting color is K, which is nothing but black color. So then we have to mention the time range. Data of interest is nothing but the quake data. So I will show you the output graph generated so that you can able to understand or visualize how the output looks like. So this one you can see the acceleration. So vertical, north, south, east, west. So these are the three variables. And this 8, 9, 10, 11, 12 are the timing values calculated in seconds. So the acceleration value is plotted here. Now we are going to see the next figure, which is nothing but velocity. So velocity and the position. So position, we have mentioned that we are using three types of position, namely east to west, north to south, and vertical. The velocity for each position is marked here. You can see the corresponding color in the legend graph. And the next graph is nothing but just we have plotted the position wise thing like vertical and the north to south. Similarly, coming for the next graph, if here you can see the same thing. So in figure number 4, in the previous figure, we have seen only the two position. Now here we have drawn a graph with all the positions. So east west with respect to vertical is this graph. East west with respect to east west itself, this graph. Here when you do right click, you can see the corresponding value for that edges. And the last figure generated is we have obtained that graph in the form of 3D graphs. So position. So position you can see we are mentioning as vertical east west and north to south. So you can rotate this graph. You can find the X, Y, Z parameters values. So all the outputs are displayed in the form of codings, as well as all the outputs are displayed in the form of figures, as well as since these numbers are obtained in the form of a table also in the command window. So you can just maximize the command window. You can drag the thing so that you can visualize more. Here you can see the timetable generated with respective to time and the three positions, which is nothing but the variables. So for the value of 0.005 second, east to west, the position is 5, north to south is 3, vertically it is 0. So likewise, the time value is getting updated and the corresponding graph is been plotted. So here you can see it is completely of explanation of that graph. So graph, if you want to display many graphs on a single window, you have to mention subplot, corresponding x-axis name and the y-axis name, title. Then you can mention the legend. So everything is nothing but the plotting only, as we have mentioned every data in Quake. Just we have to call those datas and then plot here. So this is a function. So calculating for velocity. So velocity just they have calculated using one formula like y equal to 1 by 200 into cumulative sum of x. And finally, y equal to y minus mean of y. So this is the value of y. If you feel confusing, you can mention likewise also. So the main thing is final output is y. So I will show you the first graph generated. So earlier we have seen graphs like 2, 3, 4, 5. So this is a first graph, east-west acceleration. So here you can see the analysis value obtained in our graph. Okay, so that's all about the earthquake analysis. So like this, we have analyzed the Loma Prieta earthquake. As like this earthquake, you can analyze any kind of earthquake which happened in the world, but you have to find out the data set for that particular earthquake. For the data sets, you can check the website Kaggle. So thank you for watching. If you have any doubts, you can mention in the command window.